Hello, good day to you. Welcome to Troubleshooting General. Today we will cover learning objectives, why do you need it, exercises, learning verification, and summary. Learning objectives. Why should you document while troubleshooting? Why does verification matter while troubleshooting? What do you do when under a time crunch? Do you have an escalation path for priority issues? Why do you need troubleshooting? Well, things will break. Will you have a method to use to try to get things back in order? Troubleshooting can be taught. Troubleshooting can be learned. Remember, you can do it. Okay. Understanding. Do you understand how the technologies used in the network function? If not, at least know who does and put them on your friends list. Do you have a plan to follow when an end user complains that a web page is not working? Of course, this is just a basic idea of a plan. You could verify the website is not down. Verify the issue affects a single user or multiple users. Verify the user has access to the network. Verify DNS for this website. Verify the URL is correct. Verify web browser configuration. Verify the end user IP address. Verify the website IP address. Attempt to trace route to the website. Record results. And there's a chance while you're doing these verifications, you may come upon what the problem is. This is just a basic plan. You may have different, things you may want to attempt, but this is just a basic idea to help you get started. Have an idea of what would I do if an end user complained of this problem. How could I verify that things were working as intended? Or how could I identify that there was indeed a problem that needs to be further investigated? Okay. Application troubleshooting. Do you have a plan to follow when an end user complains that an application is slow? Well, sure you do. You can verify the application is not down. Sometimes they may say it's slow to respond, but maybe it's not even responding at all. So you want to verify the health of that application. Verify the issue affects a single user or multiple users. Verify the user has access to the network. Verify DNS for the application. Verify the settings for the application are correct. Verify the end user IP address. Verify the application IP address. Attempt to trace route to the application. Record results. What changed? Do you know what changed? You can check the network monitoring system for outages. Of course, a properly configured system will provide, some sort of alerts for critical issues, but there may be less critical issues that may have some type of outage, but they're not worth paging and on call over resolving. Now, you want to check with the administrator of the service. For example, someone complains that your internal SharePoint website is not working. Well, have we checked with their SharePoint administrator? Did someone violate Read-Only Friday? Read-Only Friday is this mythical thing. Well, in some cases mythical, in some cases real. But in some environments, office environments, you don't want people making changes on Friday right before a weekend, because then you may not be able to enjoy your weekend. Now, also, there could be a hardware failure. So, what changed in the environment that we have a problem that we're troubleshooting? Known good. Do you have anything known to be good to compare against? Because if something is working and something is not working, you can see if you can discover what is different between the two. And the more similar the things are, the less differences you will have to account for. Any differences spotted could be investigated. If you have a backup of the configurations, you can compare what is currently running versus what is in a backup. Likely cause. Do you know a likely cause of the problem based on past events? Actually, I do want to say now, hopefully, if you could actually resolve the problems and fix their root cause, you should not be getting another problem caused by the same thing. But you never know. You may have, in this case, a John Doe who plugs in a space heater and blows a fuse in an accounting department. You know, so now the accounting department is up in arms saying they're having issues with their printer not working. Or did the cleanup crew disconnect the UPS while plugging in their vacuum cleaner? Check current events. Is the inauguration being streamed? What about World Cup or March Madness? No, check your network monitoring. Is YouTube eating up all of your bandwidth? Now, what are bottom up and top down? What do these things even mean? Well, bottom up means that one starts at the lowest level in troubleshooting, then works their way up. This means that troubleshooting will start with whether cables are plugged in and equipment is turned on, then eventually get to the point of asking questions about a particular application. Top down means that one starts at the highest level, then works their way back down. Questions will start with the application, then work all the way down toward whether the cables are plugged in and equipment is turned on. People often look at these bottom up and top down methods in comparison to the OSI model. That was previously covered possibly in the TCP video. The Transmission Control Protocol TCP video, I glanced over and went over the OSI model in there. So if you have questions about what that is, you can find it in that video. Now, what is better, bottom up or top down? I mean, don't you want to have a recommendation, right? Well, there is no right answer. In some cases, I start somewhere in the middle and change direction based on results. If results indicate the client doesn't have a proper IP address, then I go lower and worry about if the client's plugged into the correct location and on the correct network. If the client does have a proper IP address, then maybe I then start looking into trace route or DNS or application issues. Learning verification. Why should you document while troubleshooting? Why does verification matter while troubleshooting? What do you do when under a time crunch? Do you have an escalation path for priority issues? Now, you should document while troubleshooting so that you can make note of what has been tested and what has not been tested. Also, these results can be reviewed by future troubleshooters, the same way scientists can review the results of other scientists' experiments. You know, so you can attempt to replicate those same results. And if things are consistent that are wrong, then maybe you can try to figure out, okay, how can we repair this issue since we can replicate the problem? Now, verification matters while troubleshooting because you need to validate what is occurring. Now, take your time to troubleshoot correctly. A quick workaround today is a 5-alarm fire tomorrow. If necessary, escalate high priority issues to an SME, subject matter expert. Please note that if basic troubleshooting has not been done, those same steps will need to be performed anyway. Note, implementing too many workarounds instead of actual fixes can pile up a technical debt mountain in your network, which can lead to an avalanche of problems. Know how the application/system normally works, if possible. Troubleshoot step by step according to how the application SaaS system is supposed to work. This is why it helps to know how it's supposed to work. Now, if needing assistance, escalate to the subject matter expert SME for the application system. If the SME needs assistance, escalate to the vendor for the application or system. And that concludes the first of 2 classes on troubleshooting. Thank you very much.